Hello and welcome back. Welcome to Calculus 2, the second series I am doing on my channel. Thank you all for tuning in to Calculus 1. I hope you're all returning, and welcome to the new viewers as well. So at the very end of Calculus 2, we talked about U substitution. And basically what that was it was the reverse chain rule. So what we can say is the derivative with respect to x of f of g of x equals f prime of g of x times g prime of x. What I'll actually make this is just f of g of x prime. And so what we can do here is we can integrate both sides. Remember, when we integrate a derivative, we just get the original function. So f of g of x equals the integral of f prime of g of x times g prime of x dx. And that's essentially what our chain rule is we have our inside function, we find the prime of that and add it onto our dx, and that's what it is. Of course, we would have our plus c over here. That's how integration works. So what I would like to talk about now is the reverse product rule. And it's a little more complicated than the reverse chain rule, which is strange because the chain rule is a bit harder, I guess, for derivatives. But let's get it going. So we'll say f of x times g of x, and we prime both of these. We remember it equals f prime of x times g of x plus f of x times g prime of x. Now this is getting a little complicated. So what we're going to do is we're going to let f of x equal u, and we're going to let g of x equal v. This is what we use for integration by parts. So if we integrate this prime, we're just going to get the original function. So we'll get f of x is u, we'll get g of x is v, and this is going to equal the integration of f prime of x g of x, which is the integration of u v prime, plus the integration of, this is u prime v, v u prime. Now we can represent our u as our u prime. We're going to rewrite these. Integration of v du dx because we're integrating with dx's. I'll put the dx's back here because dx over dx just equals 1, so that's the same. That's those are going to cancel out. So what we're going to get is v du dx, because u and v are functions of x, as we saw up here. So what we're going to see is what we're going to get is uv equals integral of v du, because these dx's cancel, plus integral of, sorry, I keep messing this up. This is u times v dv dx. I must have written this wrong again. Yes, this is, the v is primed here. Okay. Get rid of these dx's, u dv. So what we have here, let's rearrange. Let's bring this over to the other side and flip the sides. We've got the integral of v du equals uv minus the integral of u dv. kind of hard to understand quite yet, but let's look at an example and maybe you'll understand a bit more. Okay, so our example is the integral of x squared ln x dx. So, let's think of this as the integral of u dv. We know this equals uv minus integral v du. So, which one do we think, when we derive it, is going to become a more simple term? That's going to be ln x because it becomes 1 over x. So the one that we want to derive, we make u because we have a du over here. So u equals ln x. Let's derive this. Du equals 1 over x dx, because du over dx is 1 over x. Bring the dx over. This is what we call the differential. And then our dv is going to be x squared dx. So dv equals x squared dx. So now we have every term in there accounted for. And this basically means dv over dx equals x squared. But what we're going to do is we're going to integrate both sides to give us v equals the integral of x squared dx. That's easy. That's 1 over 3 x cubed. We're not going to add our plus c just yet. I know that's a bit confusing, but we don't want to integrate our c. So here we have it. Our integral of x squared ln x dx equals, well, u is ln x, okay, so we need our u and our v at the start here, 1 over 3 x cubed ln x minus the integral of v du. So we've got 1 over 3 x cubed times 1 over x dx. And now we see this becomes a lot more simple. This equals 1 over 3 x squared ln x minus, let's take the 1/3 out, integral of x squared dx. Easy stuff here, just a power rule. 1 over 3 x squared ln x minus 1 over 9 x cubed plus c. And that's where we add our plus c. I noticed I made a mistake here. This is an x cubed, as we've seen here. There we go. That's the answer. And so that is integration by parts, and that's also technically the inverse quotient rule as well, because the quotient rule is just a product rule with a chain rule worked into it. You can find that out for yourself if you want to derive the quotient rule. Maybe I could do a short on that or something. But yeah, thanks for watching. And we will be talking about plenty other integration techniques and applications of integrals within this series. I hope you stay tuned. Thanks for watching this episode.